Now let's review all of our graphing here. First thing I want to do is identify my vertex, which is going to be at positive 3, negative 1, changing the sign of that negative 3 to the positive 3 in the vertex. This 2 out in front, because it's positive, tells me that this graph is going to open upward and be a little bit steep. So let's first plot the vertex at 3, negative 1. Now that kind of slope out front of 2 tells me I can go up 2 and over 1 to get to my first point on either side, but I can only go that far by rising 2 and running 1. Beyond that, I'd have to use an XY chart or plotting some other form to get additional points. For number 2, our vertex will be at negative 1, and that negative 2/3 out front tells us it's going to be opening downward. So here we go. Negative 1 is down here in the third quadrant. I can go down 2/3 and over 1. Notice I'm going to have a y-intercept at 0, negative 5/3, and a matching point over there on the left. And so that would be basically the curvature of this parabola. Find the vertex of this quadratic equation and state 2 additional points on either side of the vertex. We're going to begin by completing the square to find the vertex, and to do that I'm going to slide that 2 over, writing this as y equals 2/3 x squared minus 6x, leave a blank, plus 2. Then I need to factor out this leading coefficient of 2/3. Y equals 2/3 times x squared, and this is where we start to get into a problem. You are not going to multiply by 2/3 when you're factoring, you're dividing. You're actually multiplying by 3/2. So negative 6 times 3 is negative 18, divided by 2 is negative 9. So we have negative 9x blank, close parentheses, plus 2. And if you want to double check that, we have 2/3 times negative 9 does make the negative 6 on the line above. Now we can begin the complete the square process, and we will start by cutting in half this linear term. Negative 9 cuts in half to negative 9/2, which squares to 81/4. But that's not really 81/4 because 2/3 is distributing to it, and the 2 will cancel with the 4, the 3 will cancel with the 8. That's really a 27/2 that we've added to the right side of the equation, so we need to subtract 27/2 to compensate for that. Then we will complete the square. Let's put our x in, our parentheses, our quantity squared, our 2/3 out front, our y equals. Then this whole number 2, which is a 2/1, can be thought of as 4/2, so that we have a common denominator. And 4 minus 27 makes negative 23, so we've got negative 23/2. Now it's in completed square form, and we can identify the vertex to be positive 9/2, comma, negative 23/2. Now we need to find 2 points on either side. Now one way to do this is to say, hey, that 9/2 is really a 4.5. So let's go 1 point to the left, and that would take us to 3.5, also known as 7/2. And to the right to 5.5, which is 11/2, comma, some y value. Now the y value is going to be the same on both sides due to symmetry. Now, that 2/3 coefficient out in front is not a slope, but it acts like a slope for the first point out. So what we're going to think of this is rising 2/3 and running 1. And if I were to take this negative 23/2 and add 2/3 to it, I can get something over 6 plus something over 6. That becomes negative 69/6 when I multiply by 3/3, and 4/6 when I multiply by 2/2, and that will give us negative 65/6, which is the y value in each of those cases. So that's 1 point on either side of the vertex. You cannot use that rise 2/3 run 1 trick again, so you need to choose something else. And what I'm going to choose to do is go all the way over to 0, because that's easy to substitute into a function. When I take 0 going all the way back up to the original problem and substitute it in for x, I just get y equals 2 there. And that's a nice clean point on that side of the curve. Now that's 4.5 points to the left, so let's go 4.5 points to the right. That would be at 9 at the same height of 2 due to the symmetry. For number 4, we've got some fractions involved, so here we go. Let's factor out negative 4/3, have x squared plus, now let's take this and go 16/3 divided by 4/3. That means we're going to be multiplying by the reciprocal 3/4. See how the 3's will cancel? 16 over 4 is 4. So we will have a plus 4x, leave a blank, close parentheses, minus 19/3. I'm glad that's nice and clean. Okay, now let's subtract the 4, get a 2, which squares to a 4, but that's really a negative 16/3, so we want to add 16/3 over there at the right to compensate. Completing the square, I have x plus 2 squared, a minus 4/3 out in front after the y equals, and subtracting on the right we get negative 3/3, which is negative 1. So despite how ugly that problem looked, we've got a rather clean looking vertex of negative 2, negative 1. If I go 1 point to the left and the right, I will get to negative 3 and negative 1 as x values, and I can go down negative 4/3, down 4/3. That will take me down to negative 7/3 as a y value, and by symmetry I have that on both points. I think on the right I want to go to 0 comma something, which means on the left I'm going to go to negative 4 comma something, and I'm going to substitute 0 into the original equation and just get negative 19/3 coming out, and by symmetry I'll have that over on the left also. Number 5. We can easily see that our vertex is going to be at negative 2, positive 1. So let's plot that over here in the second quadrant. Because our kind of slope is negative 1/2, I know that I can go down 1/2 and over 1 in each direction. That's going to take me to negative 1 comma 1/2 and negative 3 comma 1/2. It's probably going to be easiest to go to 0 as my next x value, and up in the equation I can see that if I substitute 0 in, 0 plus 2 is 2, squares to 4, 4 times negative 1/2 is negative 2, add the 1 on, we get negative 1. And so 0, negative 1 will be on the graph, as will negative 4, negative 1. Plot those 2 points there and there, and it pretty much looks like it's consistent with the other points, and we probably know we haven't made any errors.